You might be surprised that there are some places around the world where you can literally boil water by just waiting a few minutes for it to heat up enough. And if we could bottle this power from the earth and harness it in more places, we could have an almost limitless supply of clean energy. Today, we're gonna see how scientists are bringing that dream closer to reality with new technology. The steamy pools and bubbling mud pots of Hot Springs National Park may seem like your typical scenic vacation spot, but what if they were also a source of endless energy? Imagine walking along the park's boardwalks and stepping onto tiles that light up under your feet as you take in the views. That's the idea behind the world's first geothermal visitor center, which opened in 2021. It harnesses the park's natural geothermal energy to power interactive exhibits and even a small cafe. While this is a tiny scale version of what's possible, scientists are working on ways to tap into geothermal power all over the globe. So how does it work? Let's start at the source. Deep inside the Earth, temperatures can reach over 5,000 degrees Celsius. But the Earth's crust is so good at conducting heat that these high temperatures only occur about 5 kilometers below the surface. In fact, just 1 meter below ground, the temperature is usually between 5 and 10 degrees higher than at the surface. In places like Hot Springs National Park, groundwater gets heated by the surrounding rocks and then rises up through cracks and fissures, creating hot springs and geysers. But much of this heat stays trapped below ground or is lost into the ocean. Until recently, accessing it has been difficult because drilling into the earth to get to these hot rocks requires long, narrow holes. That not only takes time and money, but also poses engineering challenges. If the hole collapses, the drilling equipment can get stuck inside, and there goes your expensive rig. But one company is putting a new spin on geothermal power. Fervo Energy was founded in 2018 based on research by scientists at the Massachusetts Institute of Technology. They realized that instead of drilling a single narrow hole, they could drill many shorter, wider ones that would form a network resembling a giant heat sink. This way, they don't have to reach the highest temperatures found deep underground. Instead, they target areas where the rock is hot enough to superheat water without drilling as deep, which makes the whole process faster and cheaper. And when I say superheated, I mean temperatures above the boiling point. At atmospheric pressure, water boils at 100 degrees Celsius. But if you remove most of the air by creating a vacuum, the boiling point drops dramatically to around 30 degrees. So when superheated water reaches the surface, it flashes into steam, expanding about 40 times its original volume. This creates an explosion of energy that can power a steam turbine. So far, Fervo's tests have shown that they can extract 4 times more energy than they put in while drilling, meaning that geothermal power plants could run without emitting any carbon dioxide. That alone is a game changer. But there's more. Unlike other renewable energy sources like solar and wind, geothermal is available 24 hours a day, 7 days a week. It doesn't depend on sunshine or wind speed and can provide reliable baseload power. However, the cost of building the initial power plant is very high, and it takes a long time to recoup these expenses. In 2021, the company partnered with a major oil and gas producer to build their first commercial plant near the town of Milford in Utah. The site had already been used for conventional geothermal energy extraction, but the new technology will allow Fervo to access a larger area and produce much more power with less environmental impact. Currently, the project is awaiting regulatory approval from the US government. But even when it's up and running, it won't meet the country's energy needs. That's why scientists are pursuing other avenues of geothermal power. Some researchers are turning to man-made reservoirs to tap into a virtually untapped resource. About 80% of the Earth's surface is covered in oceans. But despite their size, the seas have only contributed about 5% of the world's energy production because seawater is not easily accessible. However, one team from the University of Southampton may have just cracked this problem. Their proposed design consists of a plastic tube filled with thousands of tiny aluminum fins that absorb heat from the water and release it at the surface in the form of steam. The team tested a smaller version in a tank and found that it worked well enough to justify further research. If the full-size device performs as expected, it could generate enough electricity to power up to 1 million homes. While that's still a long way off, it's worth noting that the oceans cover about 70% of the planet's surface and reach depths of up to 11 kilometers. So the potential for geothermal energy is truly massive. Other scientists are taking a different approach by harvesting energy from within the Earth's crust itself. According to the U.S. Energy Information Administration, Enhanced Geothermal Systems, or EGS, use man-made reservoirs to deliver reliable geothermal energy in places that weren't previously suitable. Here's how it works. A well is drilled deep into the earth, and water is pumped in to create an underground reservoir. The hot rock surrounding the well heats up the water, which then turns into steam and powers a nearby turbine. Any leftover steam is condensed back into liquid form and pumped back into the reservoir to keep the process going. Sounds simple, right? Well, there are challenges like preventing the water from simply flowing back out of the well. To solve this, engineers use a variety of methods to keep the water in place. For example, in places where the rock is naturally fractured, they pump in a gel that solidifies and creates a barrier. In other places, they drill multiple wells and pump water from one to the other to keep the reservoir isolated. One EGS plant has already been built in Germany. The plant started operating in 2016 and produces enough energy to power about 150,000 homes each year. Although EGS plants are generally more expensive than traditional geothermal plants, the price of electricity is decreasing as the technology improves. Plus, unlike fossil fuels, the cost of geothermal energy doesn't fluctuate with market prices. But perhaps the biggest advantage is that geothermal power is environmentally friendly. Most geothermal plants emit little more than water vapor, although some do release small amounts of carbon dioxide and other gases. However, even these emissions are much lower than those produced by burning fossil fuels. With all these benefits, it's no wonder why governments around the world are investing in geothermal energy. According to the International Energy Agency, worldwide geothermal capacity grew by nearly 10% in 2021 alone. As we look to the future of geothermal energy, there are many exciting developments on the horizon. One company is developing a low-cost, low-temperature system that uses organic working fluids instead of water. These fluids can harness heat from lower temperature sources and still produce useful amounts of energy. Another company is exploring a method called binary cycle technology, which can generate electricity from even smaller temperature differences. Meanwhile, a group of French researchers have designed a geothermal plant that could fit in your backyard. Known as a green genius, this system uses a closed loop of circulating fluid that heats up as it moves through pipes buried in the ground. Then it powers a small turbine before cooling down and starting the process all over again. Perhaps the best part is that geothermal energy could play a vital role in achieving net zero by 2050. According to a report published by Ember, a non-profit organization dedicated to clean energy, geothermal could provide 15% of the world's electricity by mid-century. This would require significant investment, but the payoff would be huge. As we continue to develop new technologies and explore innovative ideas, it's clear that geothermal energy has the potential to power our world for generations to come. Now watch what happens when you drop a penny into a 1,000-degree furnace. Or check out how nuclear fusion works.